Ladies and gentlemen, please welcome Dr. Stephen Jones.
Thank you. Thank you very much. It's just a pleasure to be back in Boston. It's been a number of years since I was here. And I was with the Idaho National Engineering Lab, now the Idaho National Lab. I came out here a time or two with regard to my fusion research, and it's just a delight to be back. As the title says, I will discuss another discovery. I'm not going to tell you what it is, but there aren't many people in this room. I think there are 4 of us, counting myself, that know about this, and I want to announce this discovery today. It is important in this research that we're engaged in. I want to remind you, with the scientific method, we gather all the facts that we can. We do experiments. We use microscopes, as you see there. And then we draw a conclusion. What's called the political method starts with a conclusion, and then you find facts that support that, and you ignore other facts. That's not the game we're into. We are looking to get at the truth, and so we want to gather all the facts that we can. I appreciated Richard Gage's remarks earlier today. Excellent talk. He's a very fine speaker, and I really appreciate all what he's done pulling all these data together. I want to emphasize a couple of things. There is a distinction between a partial collapse and a complete collapse. I get this from those who support the official theory. That is, they say, well, there are buildings that have collapsed with fire, but not complete collapse. These are all partial collapses. And if there are any examples of a complete collapse of a building due to fire, I'd like to know about it. I've looked high and low. On the left here, you see an inferno that engulfed this building in Madrid, Spain, and the structure stood. After about 24 hours of this conflagration, the building, that is the frame of it, still stood. There was a piece of it that sloughed off up here. That's what you expect. I mean, that can happen, a piece of the building falling off. We could call that a partial collapse. Similarly, in the Boston Globe, just about a week ago, I wrote a letter to the editor. I don't think my letter was published, unfortunately, but there was an experiment done with a model building, 1/8 scale, and they knocked out one of the support columns to see what would happen and to take measurements. You see, a very good idea, an experiment. I like that. Well, what do you think happened? Partial collapse. That is, it did not completely collapse. In the article, they emphasized the building held the structure. Now, on the other hand, with the towers and World Trade Center 7, we have a complete collapse. The structure, the support structure, particularly the core columns, are decimated. Concrete has been pulverized to a considerable extent. And of course, in the case of the towers, as Richard said, the beams were thrown horizontally large distances. Now, how do the official theorists, I like to point out this is an official conspiracy theory. After all, the 19 hijackers did not work individually and alone. They worked together. That's a conspiracy. So the official story is, how did the towers come down? Besant and Verdure published a paper in which they said this upper block, so they're referring in particular, well, both towers, the upper block remains, they call it a rigid body, an intact upper block of floor that acts as a tamper, also referred to as a pile driver. As I saw that, you see the arrow pushing down, knocking the rest of the building down. And then when you get to the ground level, suddenly then this upper block is finally destroyed. Now, as soon as I saw their argument, it occurred to me how hard it is sometimes to persuade engineering students that I taught for over 21 years, that the third law works all the time. And that means that if there's a force down, the upper block pushing down on the building, then there's an equal and opposite force up, pushing up on that block. Whether it's accelerating, constant speed, stationary, doesn't matter. Newton's third law holds in all cases. There are equal and opposite forces. Now we learn that, but to convince some people that is tricky. But it is true. There is an equal force up. They need to have an arrow here pointing up. Now furthermore, the upper columns, as you go up, the support columns, the core columns get smaller. That is, the steel is thinning out as you go up. So if anything, the upper columns will be affected more than the lower columns. You don't expect that upper block to remain as a rigid block. Their whole explanation misses this. And NIST, National Institute of Standards and Technology, only takes this collapse of the towers to the point of initiation. They use the term poised for collapse. That's as far as they go. So they don't look beyond this. Besant and all do, but they then rely on this argument, which, let's see how it looks now. We've slowed this down for you so you can see the upper block. Is it remaining intact, or does Newton's third law hold? The pushing up is causing some destruction of that so-called rigid or intact body. It doesn't stay rigid at all. You see, we can see it in the data. Richard showed that for the South Tower. This is the North Tower. South Tower as well. That upper block of floors leans over. It's destroyed during the initial few seconds. It does not remain as a block. So this model of the tamper just fails completely. And I want to emphasize that, in terms of physics, there is no good official explanation. Let me follow up on that statement, the official explanation. On April 11th of this year, I and a bunch of others, Kevin Ryan, Richard Gage, Scholars for 9/11 Truth and Justice, family members, thank you, Bob McIlvaine and Bill Doyle, we wrote a request for correction, it's called RFC, to NIST, saying, look, there are errors in your report. Would you please correct these errors? They did actually admit and correct one minor point. But here's what they wrote in their response letter to us. In September, they wrote back. This is quoting the NIST letter now to us. Think of yourself as a family member or a scientist, and you're just hoping they're going to correct their report. We, NIST, we are unable to provide a full explanation of the total collapse. They admit it. They can't explain it. And they said, no, that should satisfy you, go away. Obviously, we're not satisfied. We agree with them that they are unable to. Incidentally, we can explain the total, complete collapse using explosives. Right. Yeah, thank you. And you can read about, that is, our request for correction and NIST's reply are both in this Journal of 9/11 Studies. So you'll find it there. By the way, there are now nearly 100 papers by scholars, scientists, engineers, and others in this journal. And along with Architects and Engineers for 9/11 Truth, I'm a member of that, as well as Scholars for 9/11 Truth and Justice, and a couple others, I think. But we're all working together. I'm with you, many of you. I'm sure most of you are working together to spread the facts about this. I get this question raised rather frequently. In April, there was a section of a freeway that fell down in Oakland. And I had just recently an email of someone saying, well, there you go. This explains the tower's collapse. Well, no, it doesn't, of course. First of all, this is a partial collapse. You see there's an overpass. This is quite a complex set of freeways here, of roads. And the upper one fell, but the lower one did not collapse. The columns below did not collapse. This is what we expect. There was a big fire There was some damage here. The asphalt flowed and the thing fell, but below the structure held. This is what we expect in the towers. We expect the upper structure, if it starts to move, grant that, it could happen, but then it should stop. And again, in the Journal of 9/11 Studies, you read the papers by Gordon Ross and math professor Ken Cutler, you'll see this is our prediction. Using physics principles, conservation of energy, conservation of momentum, which is equivalent to Newton's third law. I won't go into explaining that, but it turns out conservation of momentum, third law are hand in hand.
This straight-down collapse is the whole point of controlled implosion, which only a few companies in the world are qualified to pull off. Third, these buildings collapsed at virtually free-fall speed, which means that the lower floors, with all their steel and concrete, were offering virtually no resistance.
I had to put my friend David Ray Griffin in, and as he talks about the collapse of the building. Again, if you want to get up to speed quickly, I recommend this Journal of 9/11 Study. Here's some of the authors. Professor Griscom, Professor Griffin, Laurie Manuel has written an interesting couple of letters about the psychology of trying to reach people as you discuss 9/11. Kevin Ryan, Graham McQueen, and this fellow over here. Now, I want to draw a distinction. Another important, so we talked about partial collapse versus complete collapse. That's one thing. Don't let these guys that argue back at you throw this at you. Oh, there's lots of buildings that have collapsed. No, not complete collapse. None due to fire, except World Trade Center 7, supposedly. Wasn't hit by a plane, and the towers. All in the same day. It's quite remarkable when you think about that. There's another distinction here. Oh, but while I'm thinking of that, Kevin Ryan wrote a response to Mackey that came up in the question-answer period, and Kevin's response is in the Journal of 9/11 Studies. Was it November, I think we published that, yeah, if you look in the November volume. Now there's a distinction between air or flame temperature and steel temperature. Now when you light a fire, let's see if I can show you this. I actually have a piece of steel here from the World Trade Center. As I wrote this paper, it came out online November of 2005. I requested samples. People sent me samples. It was wonderful. I include dust. I'll talk about that at some length. And then this sample of steel from the World Trade Center was left over from a monument. There are several monuments around the world with World Trade Center steel in them. This was left over from one of those. So he just sent me a chunk, and I had a friend slice off a piece. Now, here's a flame. Let's see if I can get this to work. I'm not a smoker. They were showing me how to get this to work. Thank you, gentlemen. Okay, now at the tip of the flame, it's very hot. It could be around 1700 centigrade it's probably butane, isn't it? It's around 1700. Now, the steel melts at 1500 centigrade. Is it melting? No. Is it likely to melt? I was hoping I could just have someone hold this for an hour. No, it won't melt, folks. The steel temperature is much less. Why is that? Well, part of the reason is the heat is transported. Heat transport, we call it in physics. Wicked away. The heat is wicked away from where the flame is hitting the steel and carried away. And inside the towers, you see this enormous heat sink, we say. So you could build a bonfire here. Go ahead, pile up all the office paper and wood and just set up a bonfire. It's not going to melt the steel. Now again, it might warp it sufficiently so you get sloughing. That's what we say is fine. We understand, we accept that. But to have the whole thing completely collapse or to have steel melt, no, those two we rule out. And again, the distinction I want to emphasize here is the steel temperature is less than the air or flame temperature. Now, according to NIST and Eager, the maximum temperature of the fires in the World Trade Center is, or was, about 1,000 centigrade. By the way, in response to the question earlier regarding how hot were the fires in the World Trade Center, well, I'm going to go ahead and quote that. This is steel temperature now. But let me, and I'll have some other quotes on the temperature, but let me emphasize that the smoke, we've seen it, billowing, we just saw it again, out of the towers was black. It was a dark gray or black. As pointed out even by Professor Eager, this means that these were oxygen-starved fires. This is not a blast furnace situation. Oxygen-starved, according to the data that we get from the smoke, the black color. Copious smoke and a dark color means cooler fires than the maximum. You saw when I lit that lighter, there was no smoke coming off. There was plenty of oxygen, not that you could see. So the steel structures, according to NIST, show no evidence of exposure to temperatures above 600 degrees centigrade for any significant time. I'll mostly use centigrade. I'm used to it. That means the steel temperature, all right, less than 600. Now melting is at 1538 for this structural steel. And it plus or minus a little, but over 1500 centigrade. Now, quoting from NIST, and on this I agree with them, in no instance did NIST report the steel in the towers melted due to the fires. The melting point of steel is about 1500 Celsius, 2800 Fahrenheit. Normal building fires and hydrocarbon, and this is their expression here, e.g. jet fuel fires, generate temperatures up to about 1100 Celsius, 2000 Fahrenheit. NIST reported maximum upper level air, not steel, air temperatures of about 1000 Celsius, 1800 Fahrenheit. So, the maximum air temperature is 1,000. Steel melts at 1,500. This will be on the test, so please pay attention to that. And so you see that there's a big gap there, a temperature gap that we've talked about. Richard, I'm going to emphasize that temperature gap is one of the big key missing elements, a key question that we have to keep throwing out because it's extremely important. There's considerable evidence for melted metal, not just steel, as you'll see shortly, because we've analyzed this material, the drops that we found in the dust. Okay, let me not spend too much time on this. A wood-burning stove, I have one. It's never melted on me. I also have a kerosene burning stove. Jet fuel is a type of kerosene. I'm not worried about it melting either. And now, in the dust, there are spheres that are rich in iron. These are spheres that I took with a colleague using the, okay, Richard, what's the trick here? Oh, there we go. Okay, I spray out, this is water. It's acid. This is water. And if I spray it out in a fine spray, all right, fairly fine. Can you see that a little bit? There's droplets that form. What form does the liquid drops take right away as they get into the air? Spheres, right. And why is that? It's because of surface tension pulling that into a sphere. See? You know it's a liquid when you see the sphere, because if it was ice, it wouldn't form into a sphere. Besides that, it's too warm for ice. There's a parallel there too, but I won't pursue it. With the dust, we observe, as I've reported before, you'll find it in the Journal of 9/11 Studies, May 2007 issue, my paper on the spheres. This is the early paper on these spheres. We have an abundance, thousands in a tablespoonful of this dust, for example. And others have reported these spheres, as we'll see. Now, again, steel melts at 1,500 centigrade, about 2,800 Fahrenheit. The maximum temperature of the fires was about 1,000 centigrade. That's a 500-degree gap. How do we get all these iron-rich? Now, I'm not saying steel. We'll see in a moment. We've analyzed these. These are not steel. That's another point. Even if you melted the steel, these are not steel. Some of them actually do look like steel, but it's melted. I mean, as you cut through steel, you're going to get some steel drops, but also what you cut with is going to form drops. Okay, some of you know I'm leading up to thermite there, but we see an abundance of these spheres, very high temperature. Notice this one is hollow. See the piece that is chipped off? We see that quite frequently. It's interesting for some of you scientists to pursue. What makes these hollow? But actually, we see that in thermite also. You get spheres, and a number of them are hollow. Now, the United States Geological Survey and others report the existence of these spheres. This is from the USGS report. I called up on the phone and I asked one of the principal authors, Greg Meeker, nice fellow. He kept asking me, why are you asking this? Where are you from? And so on. But I was asking him, how do you explain these spheres in the dust? To me, this is smoking gun evidence for very high temperatures. I know that explosives can produce these spheres. The thermite reaction in particular is highly exothermic, energy releasing. It produces these spheres. What was his explanation for these spheres? He said, well, because there's no mention in their paper of an explanation for these spheres. And he said, well, we don't know, but we thought maybe it was during the cleanup operation where steel is being cut with an oxyacetylene torch. And now, my response was, well, we see a number of these spheres that have aluminum as well as iron. And there's another objection now. We have some dust that was collected within 20 minutes of the collapse of the North Tower, the second tower. That cannot be, therefore, due to cutting of steel, right? Steel was not being cut 20 minutes after the collapse of the towers. It was not for a while. This was during the panic stage, and later they had the rescue stage, and then finally cleanup. This is the R.J. Lee report. Again, a very extensive study of the dust, and they show here spherical iron particles, several of them. We're not alone. There's no escaping this, folks. These data are out there. They're published. Anybody, I don't care whether you're Mormon, and Muslim, Catholic, Hindu, Jew, it doesn't matter. Scientific method cuts through all belief systems. Everybody can see these spheres. Atheist, doesn't matter. You can see the spheres, right? It doesn't matter whether you believe 9/11 was due to some rogue element in the government or what. It doesn't matter. You get your scanning electron microscope, as both of these groups have done and we have done. You look at these are prevalent. I'm sure there's a number of these in Boston. And you will see these spheres in the dust. And I'll tell you how you can, in fact, oh, thank you. Thank you. If you want some dust, just write to me. I have various people now as have come forward. Now this steel, also an example of severe high temperatures. Something has attacked this steel. One of these is from World Trade Center 7. The other from the towers rubble. This is published by Barnett. You can't escape it. That is to say, it's touchable, it's tangible evidence, hard physical evidence. This is not the result of some fires. If you claim it is, please show me how to do this. Set up a fire, burn office materials, put a steel beam there, and see it turn to the Swiss cheese, thinned out material. Now I can do this with thermate attacking, which is thermite with sulfur added, attacking steel. We've actually done that with a piece of this World Trade Center steel. We've attacked it with thermate. It does punch holes in it. The thermate does. New York Times, perhaps the greatest, the deepest mystery uncovered in the investigation. Well, why then did NIST not deal with these data? Okay, evaporated lead has also been observed. This is by the R.J. Lee group. Just cut to the chase here. Existence of extremely high temperatures during the collapse, which caused metallic lead to volatilize. Evaporating lead requires 1749 centigrade, 3180 Fahrenheit. That's way above what these fires could have reached. This is hard physical evidence for some extremely high temperatures during the collapse. Folks, we're not just dealing with fairyland speculation here. These are hard data by other groups too. Ourselves, yes, we corroborate each other. It can't be escaped. It has to be dealt with then. So how do you create these iron-rich spheres? There are also glassy spheres. I haven't talked much about those, but they're also prevalent in the dust. Again, these aluminosilicates melt at above 1500 centigrade, plus or minus. Lead-coated fibers, and then the steel beams like Swiss cheese. This is what I call the temperature gap, and it's about 1,000 degrees. If you look at Fahrenheit, if you look at the temperature of the fires, maximum, 1830 Fahrenheit, to evaporate lead, so it's around 3,000 Fahrenheit. So the gap there is over 1,000 degrees Fahrenheit. It's an enormous temperature gap. And I and several colleagues have written a paper about this, and we hope will be published fairly soon. How can you explain it? Again, NIST is unable to explain the total collapse of these buildings, has not looked for the residue of thermite. They told us that. We have. We can explain this situation with highly exothermal reactions, not just burning of kerosene or jet fuel and paper and office materials, but by some other chemical reaction that releases much more heat. An example, there may be other charges such as HMX, RDX, but an example of a very high temperature reaction is the thermite reaction, in which aluminum powder is reacted with iron oxide. What happens here is the oxygen goes over to the aluminum. Basically, the aluminum wants it more. When it gets the oxygen, heat is released, a lot of heat. You end up with molten iron, and then the aluminum oxide goes off as a whitish plume. We see that here in an experiment I did with colleagues again. You see the yellow-white hot flow, and there are also some sparks. You see that in the air. What are those sparks going to do? Because they're liquid. Droplets, right, spheres. And we've collected spheres from this, and I've studied those, and I'll show you the results. So we get a flow as well as droplets, and we get the whitish aluminum oxide drifting away. From the World Trade Center, we see at the South Tower, minutes before collapse, and this is indeed the corner at which you see twisting and failure, shortly after this flow, a large amount of yellow-white hot material. And I've discussed this at length in other papers. You'll find that in my 2 papers then, which are available in the Journal of 9/11 Studies. If you notice, there's a wispy white stuff drifting away. If you look at the video of this, we now have about half a dozen videos that have been found, collected, of this yellow-white hot material. Again, you can't deny that there is molten metal at the towers, because we have we have now videos of it, and of course we also find in the dust these droplets.
You'd get down below and you'd see molten steel running down the channel rails, like you're in a foundry.
Yeah, like lava.
Like lava
from a volcano.
Okay, now let's look at what we get from the thermite. These are spheres produced by the thermite reaction. This was run by someone else now, John Perulis of Architects and Engineers for 9/11 Truth, did an experiment called the Burning Man demonstration, which was a large quantity of thermite. And he collected spheres, bless his heart, and sent those to me. Here's some more of the spheres. Notice this one is hollowed out, you see? We see that typically in thermite. A number of these spheres are hollow. And this is from World Trade Center, some spheres from the World Trade Center, the McKinley sample. They both form spheres. They both form liquid metal, mostly iron, at very high temperatures, so you form these spheres. So we got that part worked out. Oh, this is watch close. This goes fast. Okay, this is a commercially available thermite cutter for sale for demolition purposes, cutting through a metal rod. As you can see in a fraction, there's the metal rod. Boom. Now when that hot molten iron sprays out like that and cuts through the metal, what do you get from the spray? Spheres. That's right. And we see an abundance of spheres. Is anything starting to fit together here? Okay, good. I'm going to talk about the chain of custody, the provenance of these samples. We have 4 samples now that we're studying in detail. The first was provided by Jeanette McKinley from her apartment across the street from the South Tower. Let's see, I'm not sure I can see it at this time. It's right about here. It's very close to the South Tower. When the South Tower collapsed, her windows broke in of her apartment. Her apartment was flooded with dust. She covered her head with a wet towel to get out of there. And here's a picture of her going back into her apartment. You see the windows broken here? You see the big hole there in the window? And just covered with dust. She said she had a feeling, a sense to save some of that dust, realizing the lives that had been lost, and almost a reverential feeling. She collected it in a plastic bag. As soon as she saw, or shortly after she saw my paper and heard about my request for samples from the World Trade Center, she sent me some of the dust, and that has led to this rather exciting pursuit now that we're following that reveals what happened. Because you see, the dust it's like a snapshot of what happened that day, right? The windows broke in, the dust comes, the dust carries with it information, including these iron-rich spheres. Sample 2, independent sample acquired by a PhD physicist on the 14th, just 3 days after 9/11. McKinley's was about a week after. This is 3 days after, about 4 blocks from the World Trade Center on an indoor windowsill. There was enough pressure for the dust to get under the windowsill and collected inside. The scientist saved it so he could test for asbestos, which there is asbestos in this dust. Very dangerous stuff, nasty stuff. High alkalinity as well, even though the EPA said it was safe, which really bothers me. Told people to go back to work, particularly in the financial districts, and now thousands are dying, ill and dying from this dust. Estimated 15,000 people sick from breathing this terrible dust. And yet the EPA said it was safe. It's a very big concern. Scientists told them before they said that this dust was very dangerous. It's like liquid drain cleaner, one of the scientists said. Swayze was his name. He said, look, okay, I get going on those things. But it's a clear example of where the government was not telling the truth and put an interest of corporates, Wall Street, above people. Okay. Sample 3 was obtained on or about the 12th of September, so just a day or a couple days after. And this email explains, I don't know if I'll read all of this, but on the 12th, he went into the laundry room, and the window was open. It says down here about 3 or 4 inches. They closed the windows, and so he's not quite sure whether they collected the dust that same day or a couple days after. But the point is they close the window so they prevent contamination coming in. In this dust sample, we see, again, these iron-rich spheres. So that rules out now that these spheres could come from cleanup where you're cutting through steel. This is the best sample we have, and I'd like to invite Tom Breidenbach and Frank D'Alessio to come up here. Do you hear Tom? Frank? Please come up, guys. I'll let them explain a little bit how they collected this. What I want to emphasize is that this was collected by Frank, as a student at a university, within 20 minutes of the collapse of the North Tower. So let me turn that over to Frank just for a minute, would you, Frank?
Hi. That morning, I was on the A train heading into Manhattan at a class early that morning, about 4 blocks from the Trade Center. I was on the last train that was the last train that stopped at High Street, Brooklyn Bridge. They informed us that no more trains were allowed to enter Manhattan due to a collapse. As I left the subway, there was a string of people coming from the Brooklyn Bridge. I followed my way onto the bridge. There's a mass exodus coming my way. Me and another girl were the only two people going towards Manhattan. I had a camera. I took a whole roll of photographs really rapidly. As I entered the Manhattan side of the Brooklyn Bridge, that's when the North Tower fell. And soot just came. We couldn't see. I fell. Then I was exiting the bridge. I scooped up a whole bunch of soot on the rail. It was piled up, sort of like snow, and then proceeded to head north towards the East Village, where I met my friend Tom.
Where did you put that?
Oh, I just carried it in the palm of my hand. Yeah. You know, it was history, show and tell. I knew that no one was really near there besides me. They weren't allowing people in specific perimeters. So it was it was just instinctively that I grabbed it. I was wearing a black button down. I was covered in soot. Yeah, I thought that would be something to hold on to. So I did swipe it from the rail. And then when I entered Tom's apartment, he was kind of shocked because had it in my beard and hair and clothes, and I showed him the sample, and we immediately put it in a Ziploc, and he's held on to that since then.
Isn't that great? Say a word or two, would you, Tom?
Yeah, I'll just add that he came in and was covered with dust and showed me this dust that was in his hand, and we didn't know what to do with it, and I thought we were in shock, so we just put it in a bag, and I've been following 9/11 Truth closely for a while, and it wasn't until recently I watched a lecture of Dr. Jones's where he said we need more recent dust, so I got a hold of him and we sent him this sample. And I'll also just add that we later had gone down to see what was going on, and we were about 5 blocks north of Building 7 on the west side of the West Side Highway when about 20 minutes before it came down, we were told that they're going to bring it down. Remember, the gentleman about 15, 20 feet ahead of me turned around and said they're going to bring it down, and we were all looking at it and completely expecting it, and everybody's around us has our eyes just focused on Building 7 when it did about 20 minutes later just come down. So.
Isn't that amazing? Thanks. Let me ask you, gentlemen, did you add anything to the dust? Did you sprinkle it with iron spheres? Or?
No.
You'll be asked that in court someday probably, but thank you very much. Okay, you hope so, he says. Thank you. Thank you, Frank and Tom. So, World Trade Center 7 was still standing when the sample was collected. There was no cutting yet of the steel, obviously. It's an uncontaminated sample, just what we've been waiting for, to confirm that this is not due to contamination. It's in the dust. Something happened during the collapse. Now, I announced last April that we saw spheres with aluminum. These peaks represent the elements present in this sphere. Aluminum, sulfur, and iron. Aluminum and iron is a signature for thermite. Remember, it's a reaction between aluminum and iron oxide. And so in the sphere, liquid then, it was liquid at one time, formed a sphere, you see residue from the aluminum and, of course, a lot of iron. And if they add sulfur, then you see that, as you see here. Sulfur makes this molten metal cut through steel faster. It's not required, though. That thermite cutter, as far as we can tell, does not have sulfur added. It doesn't need it. You just blast through with that hot jet of molten iron. I talked about the fact that in Thermate, which I designed myself then to try to match what we saw in the World Trade Center. Let's see, which is which. 15th of March, this is the Thermate. I did that after we had observed the content. You can see I got pretty close, aluminum, sulfur, iron in both cases. So I can make a thermate easily that matches what we observed in the World Trade Center. Now, It's been 8 months, and we've analyzed hundreds of these spheres since then using these state-of-the-art methods. XEDS stands for X-ray Energy Dispersive Spectroscopy. That will be on the exam. XEDS will be on the exam. Okay, I'll make it easier for you. It's a method where we send electrons at the sphere, and X-rays come back, and the X-rays are characteristic of the metal or elements in the sphere. Mostly what we see now, that is, a lot of these spheres show this pattern. A lot of the iron-rich spheres, there's a lot of glassy spheres as well, but the iron-rich spheres often have, in addition to aluminum, see the aluminum peak, the iron peak, silicon, and of course oxygen in large quantities. You expect that because, for instance, aluminum oxide, also the hot iron will react in the air to produce iron oxide. And then potassium is very interesting, very characteristic. So I want to clarify or add to now the body of knowledge about these spheres. I haven't seen this published anywhere, but we see a lot of this. Here's some more, just to give you some examples. Put this on the record. Aluminum, the same. I've written it out here. Fe Fe is iron, K is potassium, oxygen, aluminum, silicon, Fe. Okay, that's what we see, a lot of these. Again, this is the sample 4, and this is the Potter building. Sample 4 is Tom and Frank just spoke at the Brooklyn Bridge. Okay, I got this again. Just to remind you, boom, spray comes out of that. Molten iron spray cuts through metal, forms spheres, guaranteed. Now, this is new. John Perales, an engineer, purchased thermite commercially. Look, you can buy thermite on eBay. This is not a secret, okay? But you can also buy large quantities commercially. He did. We looked inside. I was puzzling. Where is this silicon coming from in these spheres? Turns out that commercial thermite in the iron oxide, this is mostly iron oxide, but the dark here is mostly silicon. It's silicon rich. And so you have aluminum chunks. The aluminum is fairly pure, it turns out, in this commercial mix, but the iron oxide has silicon mixed in. And when we look at the spheres, here's what we see. Does this look familiar now? Iron, potassium, silicon, aluminum, and oxygen. Same thing. The same thing, folks. Doesn't take a rocket scientist to see these look very much the same. Let's compare them side by side. Let me just ask you, which one of these do you think is from World Trade Center? Which one is from commercial thermite? There are some differences, but you see differences from sphere to sphere too. The amount of aluminum oxide that gets trapped, for example, in thermite varies. So the aluminum peak will vary just from sphere to sphere. But the same elements, this characteristic, that is the signature, Fe is common to both. This is going to be hard for the official theorists, and I believe demands now not just an investigation, but a criminal investigation. Okay. And I'd like to, I'm so glad there's a flag here. Love the flag, you know. And I love my country, but I am concerned about a number of trends in my country. I won't go into those in detail. Let's get back to the science. But I just want you to know that I love my country, and I believe that we still have a constitution, and we still have a chance to turn things around and have a much better society based on 9/11 as a pivot, a turning point, and a basis for change. Okay. Okay, so the top then is raw thermite, the unreacted thermite, and when you react it, you get these spheres. Something has produced very similar spheres. As we look at it, this similar chemical signature, very much the same in the spheres as we find in commercial thermite. Now here's the new discovery, the question I want to pose today. Could we find unreacted thermite in the World Trade Center dust? We see the residue. This is the smoking gun already, but can we find the gun, I guess you'd say. The unreacted thermite. Ta-da! Many red chips I found in the World Trade Center dust. About last June, I started noticing these. They're attracted by a magnet. A thought came, well, maybe it's just paint. There's all over these little red chips. They're like eggshell chips. You know, you scrunch up an eggshell, and you get about that thickness, roughly speaking. These are quite tough, though. They're strong. And now these are bilayered. This only shows one side, the red side. The other side is a dull gray. Red is the color of iron rust, iron oxide. One of the oxides, Fe2O3. It already suggests something to you. They're attracted by a magnet, suggests iron as well. And now the chemical composition, are you ready, of these chips? The red side. I won't talk much about the gray side. It's harder to analyze using this method. But the red side has, I can just hardly wait to show you. Okay, here it is. These are red chips. The one is from the Liberty Apartment, McKinley. The other is from the Brooklyn Bridge sample. These also show, can you see it? It's very clear, iron. It's hard for me to point to it from here, but I think you can pick out now. Fe is iron, Si is silicon, Al is aluminum, K, potassium, very clearly, and of course, oxygen. It's the same signature as the spheres. It's the same signature as the commercial thermite. I've put them side by side so that you can look at this. Hopefully, as this is taped, you can, pause and make your comparisons. The same signature. Again, the amounts will vary from chip to chip and from sphere to sphere. And where you look on a chip, there are some variations. And certainly where you look on a sphere, there are some, from sphere to sphere anyway, there are variations. The spheres typically are small. A micron up to about 1,500 microns. 1.5 millimeters is the largest sphere that we've seen. So here's a comparison now from the Brooklyn Bridge sample, uncontaminated within 20 minutes of the collapse of the North Tower. Again, red chip on this side. Oh, wait a minute, I'm sorry. I've got to correct the title, sorry. The red chip is from the McKinley sample. The sphere, which is here, is from the Brooklyn Bridge sample. And so, but again, you see, from sample to sample, we see the same pattern. Fiok Alsi. Okay, now this is from, so I have to look at the title. I remember red dust, I called it back then. When were those data taken? June, yeah, June, you see, of this year. This is the first time I've discussed these red chips publicly. I think it's important to get this out. We have done some other tests. Oops. I want to mention, so one of the tests I did, so I took one of these red chips and I had a friend scan. It's hard to get thermite to ignite. And I thought, how can we tell if this is thermite or not? It's not easy. It has the right chemical signature. Aluminum, iron, oxygen is what you need, and it's got some other goodies thrown in, silicon and potassium. And so typically, I put the K in parentheses. Not all of these show much potassium, but anyway, that's the signature. And so a friend of mine has an oxyacetylene torch with a very fine tip. He uses it for repairing eyeglasses. And so I had him pass it over one of these red chips. It was just 1/32 of an inch on a side, approximately square, and it flamed, it flashed as he passed over it. Now that's not itself a proof, but it's a strong indication, along with the chemical composition and the red color, which indicates iron oxide, that this is a form of thermite. I've provided red chip samples now to an independent laboratory for testing with the question to them, do they agree, do they find that these red chips are a form of thermite? The technical term is aluminothermic. Independently, Justin Keough and his team, I know he's working with Richard Gage, is now also looking at the World Trade Center dust spheres and red chips also. Excited to say. Richard called up Justin last night. I talked to him on the phone. Oh yeah, we saw some of that red stuff, you know. He said we tried it in a Raman spectrograph system analysis. And he said we hit it with a laser. Now this stuff is behaving like thermite, folks. Again, I'm inviting scientific scrutiny of these red chips. I believe this is the last nail in the coffin, so to speak. Thanks. So I don't hesitate at all. I invite laboratories and scientists around the world, not just the United States, to examine the red chips and the microspheres in the World Trade Center dust. Entertain all hypotheses, please. If you find some other explanation for these spheres, I would sure like to know about it. Yeah? Aluminum, by the way, the aluminum in this World Trade Center steel, we have had it analyzed. We have analyzed steel, is small. Of course, also the potassium and the silicon are very small in this, and sulfur is very small. When you have steel with sulfur in it, it's brittle. This is not brittle. This stuff is well, structural steel. It's strong. Okay. Okay. Here's what I think it is. This is now my best hypothesis for this these red chips. It's I guess, an extremely fine mixing of ultrafine aluminum and iron oxide. This is a photograph enhanced from a paper that came out of Lawrence Livermore National Laboratory, in which they combine ultrafine aluminum and iron oxide in a gel, a solid gel. When you do this and touch it off, this is a photograph again from this website of this paper, it explodes. This form of thermite is explosive. It's not just an incendiary that melts, it explodes. And the reason is because the very fine particles of aluminum and iron oxide allow for a very rapid reaction. Gosh, it's so exciting as a scientist to see this coming together personally. I showed some of these data to a friend, and he said, wow, it's amazing how all these studies are linking together now, supporting the controlled demolition hypothesis, and now telling you what at least one of the explosives or cutter charges that was used. Remember that thermite cutter bursting out? That's what it looks like, that sort of thing. Okay, so anyway, but then he paused. He said, it's just exciting to see that come together. And then he paused and he said, it's exciting scientifically, but I am sad for my country. And he's right about that. And I have strong feelings about that too, and about the survivors and the family members, you know, that what they've gone through. Donna Marsh O'Connor will be speaking later, and Ellen Mariani, good friends of mine, Bob McIlvain, Bill Doyle, and so on. These people have lost family. They want answers, you know. And I'm seeking those answers for them and for all those that perished and who are perishing, frankly, in these 9/11 wars, which I consider to be terrible wars. Now, let me point out for scientists, I hope I'm getting some interest built up among scientists, frankly. I mean, when scientists see things like this, they say, wow, I can study this. I know how to run a scanning electron microscope with EDS, no problem. You know, let me get some of that dust. I'll send it to you. Or actually, I'll have the finders send it to you. If we get enough requests, we're going to have to start collecting up some of the dust that's still in New York. And we can do that. You say, well, it might be contaminated, but we can compare with these samples that were acquired within 20 minutes of the collapse. Here's an unusual sphere. Jump in, scientists. Look at this one. Zinc, iron, sulfur, and oxygen. What an unusual situation. It'd be interesting to explain that. Not too difficult in terms of thermite, by the way. Zinc nitrate is a good oxidizer. Here's another one. A barium-rich sphere. Look at the barium lines. These are X-ray lines. Very clearly barium present. Some of you may have read my paper. You'll know that barium nitrate is added to a patented form of thermite called thermate TH3, patented by the U.S. military. I'm not saying that's what this came from necessarily, the military form, but it's a well-known oxidizer, barium nitrate. Now, I'm just down to the last couple slides. Someone wrote to me recently, and I agreed with him. I thought he expressed it well. If only you could get one of your papers in a mainstream science journal, I think it could be a quantum leap that would do more good than 100 conferences, okay? All right. My first paper in 2005 called for samples and photos. We're getting those. It called for an investigation. As it turns out, and Richard alluded to this too, we are conducting the investigation now. We may formalize that. Now, the result of this investigation, it's a scientific investigation at this stage, will be papers that should be publishable. I, with colleagues, have submitted 2 9/11 related papers to mainstream technical journals. The first one deals with Newton's third law. I just talked about that, as well as temperature considerations, which I talked about some today. There's, of course, a lot more detail in these papers. The second paper deals with the iron-rich microspheres. Working on a third paper, don't expect that too soon, on these red chips. Still a fair amount of work to do there, which, again, I hope others will jump in. All of this, I think, is so important, and we're just nailing this down. One paper is currently, of these 2, is undergoing a rigorous peer review now in a major journal. The other paper, and this is my concluding slide, has already been accepted for publication. Thank you.